Hello Year 7 mathematicians, and welcome to the start of a new topic. So you're going to need to draw a line under previous work and have a title of letter and labelling conventions and today's date. Now just be sure that you've got with you the accompanying worksheet that comes as a PDF document. You need to have that printed out alongside you if possible, because you're going to need to use that as we go through the lesson today. You'll need your books to put in some definitions, but you will need to annotate that sheet as they come out for me as well, please. So these diagrams will be on those sheets. It saves you drawing them all down for yourselves. So there are do now tasks on the screen. There are in fact 2 do now tasks. You can pick which one you'd like to do there. You either sort those shapes into 2 different groups, entirely of your own choice of how you'd like to split those, or you can have a look at that picture I've put on the screen there and how many triangles can you see in total. Okay, so if you pause the video and have a go at least one of those do now tasks for me, please. Okay, so looking at this first do now task, you may perhaps I'll split them into quadrilaterals, so 4-sided shapes and non-4-sided shapes. You may have gone with some polygons and then non-polygons. So a polygon being a well, actually, we'll give a definition for that a little bit later on for those of you who aren't too sure already on that, but some of you may know already, and then you can always flick back and have a go at that once you understand that. And part 2, how many triangles can you see? I believe, and by all means correct me if I'm wrong, I think there are 29 triangles that can be made in total there. Okay, so here we go for a little bit of hook, and there's a lot of sort of investigations and things I'd really like you to get involved in using that workbook. So how many triangles could you draw by linking the dots? How would you then explain where they are and describe one triangle compared to another? So say you were sat next to someone, you wanted to describe it to your parent or carer, how would you tell them where those triangles are and where they sit on those dots? If you were to add in another dot, what would happen to the number of triangles? How many more could you create? And then how again would you describe it? So we're going to build on this, how we're going to label these types of diagrams to make things a lot clearer today. So we're going to understand the importance of capital letters, be able to identify and label line segments. There's going to be quite a few definitions as well, and be able to correctly label angles and polygons using letters. So first up, have a think here. How many points do you think you need to define a straight line? And how many points do you need to define a polygon? So we'll have a think. We often think of a line as being a distance between 2 points, but we need to be more precise. One of the words we're going to look at in particular is line segment, and that is how we describe the distance between 2 points. Okay, so we need to get that definition down. The distance between 2 points is a line segment. A line is in fact an infinitely long, so infinite meaning gone forever, collection of points, and so we should place arrows at the end of our line to indicate it. So you'd show that it can go on forever. And how many points do you need to define a polygon? Well, first of all, we need to define what a polygon is. And that is a 2D shape, so it's a flat shape that are made up of straight lines. So if you had a look on the first do now task, there was quite a few sort of circles and things, and they have curved edges, in which case they would not be polygons. It must have straight lines, and the shape must be closed. They can't be open, so the lines must all meet up somewhere. Okay, polygon, if you separate that, 2 separate words, poly meaning many, and gon meaning angle. It's got many angles within it as a shape. Obviously on a circle with the curves, that's just one big 360 degrees. There's no angles you can measure on that. Okay. So let's have a look at some line segments then and some polygons. So I think these are on your worksheet, so just make sure you label these and put in the correct answers before you then have a go at the do section. So here's a line. We're going to label each end with capital letters A and B. Our line segment is the distance between those 2 points, and we write with AB with that notation with a line above it to show that as a line segment. Next one, doesn't matter, it's still a straight line, doesn't matter it's on the angle at all there. Label them up, 2 letters, X and Y, capital letters, X, Y with then a line above it. So there should be 2 on your sheet. If you can have a go at those for me as well, please, and just pause the video as you go through. Okay, so we should get CD and then EF. Okay, the general convention would be to go in alphabetical order there, so A to B. Okay, if you were to do it the other way around, D to C, that is still the same line segment. So you could do the first one D, C, but convention would be we will go alphabetically. Okay, now we need to look at some angles. Okay, first things first, we've got a shape there. It's a triangle. We need to label that shape, and we would label that again using capital letters. And the triangle would be LMN. You label all 3 letters, and again you would tend to go with alphabetical order. Now for the angle, we're looking at the angle created at where the letter M is. Now M is on a corner. We call these vertices. A corner is a vertex. The plural of vertex is vertices. So the corner there, the vertices of M. So M will be the angle we're looking for. You need to give 3 letters when describing an angle. And the angle you're looking at is the middle letter. So we would go LMN, angle LMN, M being the middle letter there. That's the angle we're looking at. Okay, so for you, there's a slightly different shape there. But still see if you can describe the shape using the letters and then tell me what that angle would be. Okay, so the shape should be GPTQ. You would go round either clockwise or anti-clockwise. I know we said about alphabetical, but you wouldn't jump GPQT. You'd follow the exact way round the shape where those lines go. Okay, and then the angle we're looking at where T is, so it's going to be the middle letter. We need 1 either side to describe it, so we'd go PTQ, or you could go QTP, because once again T there is in the middle. Okay. Another one of these. How many squares can you construct using the points labelled and use letter notation to name each one? Okay. So you might go A to B, BE, ED, and then DA for a square, and you can label that as ABED as your square. I want to see, if you pause it there, how many you can make. Okay, having a go, I believe, and again, correct me if I'm wrong here, we should be able to get 14 squares on there. Okay, let me know if you've had any more than that there. So, geometric figure is shown to the right there. We're going to use letter notation to fill in the blanks in the statement below. So, a right angle is 90 degrees, and there's quite a few on that shape. So, we could say a right angle, we can see at the vertex of C there, we could say ACD is a right angle, or you may have chosen ABD or BDC. There's quite a few on there. Now, line segments, vertical, would be looking at AC, or you could refer to that as CA, and then also BD, or refer to that one as DB. A triangle, we're looking, again, we'll go with convention for alphabetical order, A, B, E. A, B, E is a triangle. And a quadrilateral, again, few choices. You could go A, B, D, C, so you've got the overall rectangle, or perhaps you've gone A, E, D, C. Just remember, quadrilateral, quad meaning 4, it's a 4-sided shape there. So you could have gone A, E, D, C as an example as well. Okay, now if you draw one more line on the shape between 2 diagonal corners on the rectangle and name your line segment, does this create a new shape? And if you were to label this shape, what would you need to do? Okay, so have a little play around with that and see what new shape you can create, and see if you know the name of that shape and are able to add on any additional labels you may need. Okay, so this time we're going to draw a trapezium and label the vertices So remember, we call those the corners, K, L, M, N. Okay. Then you're going to draw a line segment from point L to point N and use 3-letter notation to identify the triangles formed within the trapezium. Now there's quite a lot of information there, so if you're happy, pause it and go now. I'll very slowly show it on the screen. Each bit you're confident at, pause and then continue it on your own. Okay. So there's the trapezium. We label them up. And again, I could have chosen somewhere else as my starting point for K. It doesn't matter there as long as we do label them all K, L, M, and N. We're then asked to draw a line segment from point L to point N. There's my line segment. And I've labelled that LN with the line above it. And then we use 3-letter notation to identify the triangles formed within the trapezium. Okay, so we could have the triangle LKN, or we could have the triangles LMN. And what I've also done on this one, just as a little bit of a bonus, is I have in fact labelled some angles. Okay, so we've got the angle there on the vertex of K of LKN. On this one, these are the two we're going to be very, very careful with. Note how I haven't gone past that line segment of LN. So it's the angle enclosed between K, L, and then that N. So that would be angle KLN. And then this one, which covers all of it going across the line segment, is angle MNK, where N is the middle part there. Okay, just to show the difference between those two angles. A few standard examples appearing now. Would it matter if we change the location of the letters to different points? Would this affect the names of the line segments or polygons? Okay, so just have a think there. If you swap some of these letters around, how would it change it? Okay, so first of all, if we look at the one that's AB, if we swap those letters around, AB, BA, they still show exactly the same line segment. Same with CD. The other shapes are slightly different. If we focus in on the bottom right for the rectangle, we've got the rectangle WXYZ. Now, if we swap some of those letters round, say the W and the Z, if we then read out WXYZ again, we've gone completely different in the shape because we would have to follow the outside those lines round to create the rectangle. If we go WXYZ having swapped them around, we're going to end up with some diagonals and it's then no longer a closed shape and it wouldn't make that rectangle. Okay, so you've got to be very, very careful where you're labelling them and also make sure that every vertex has got a different letter attached to it. Couple of non-standard examples on this one, some slightly different shapes, and a bit of a check to see if you can remember any of the terms involved with a circle. So, if line segment AB passed through the centre of the circle, how would you describe it? Okay. So first of all, I've got to put up on that first part, line segment AB, that one is currently called a chord. Okay. That is a chord, a line segment connecting 2 points on a curve. Now, if those 2 points pass through the centre of the circle, that would then be called a diameter. Okay? And those that remember as well, half the diameter is called the radius. So that's a point from the outside of the circle that goes to the centre of the circle. And then on the bottom left, we've got another trapezium there. I'd like you to draw another line segment in the trapezium to create 3 triangles. What are the properties of the triangle? And could I draw a line segment then creates 3 triangles and a quadrilateral? Okay, so that's a chance again for you to have a little bit of an activity and play around with that. That would be perhaps the line segment, giving 3 lovely equilateral triangles. Equilateral meaning all got equal sides. See if you can put on 1 line segment more that creates 3 triangles and a quadrilateral. Now, what we've got here is a true or false. Now, if this isn't on your worksheet, then you're going to need to just draw that shape down. I've put every single statement there, and you're going to pause it and you're going to mark true or false next to every single one, and then in a moment we'll see how we do. Okay, so let's see how we did on these true or false. There are 3, 4, 5. There are 10, so you can give yourself a score out of 10 for these. Okay, and you got wrong there. Just double check to see where you may have made that mistake. Okay. Now, this is something that we'll be seeing a lot later in perhaps mathematical life as you work towards GCSEs with us, and indeed when many of you do A-level at Delisle. These are some of the formulas we will look at. Okay, the one on the bottom left that appears first there, that is known as the sine rule. No, it's SIN, but we call it sine rule. And then bottom right, some of you may recognise that as Pythagoras' theorem. And later we will use lowercase letters to represent the lengths of sides. So it's very, very important that now we start to label correctly using capital letters there. Now, a little bit of information that we're going to need to get down into your book as well, that we've covered a few of these. A vertex is a corner, and the plural of vertex is vertices that we've been referring to. An edge is a line segment between faces, and a face is a single flat surface. Okay. So when you have perhaps a regular dice, then you've got the 6 faces, the numbers 1, 2, 3, 4, 5, 6. Those are your 6 faces. Okay. So Jagdish draws and labels his triangle and says this is triangle ABC. Is he correct or not? And what is the issue with that? Then Gareth had a go, and then Megan's had a go at some shapes. I want you to see if they're correct and what mistakes they've made if you say no. So Jagdish has made the error where he's called it A, B, and then another letter A. Okay, we need the 3 separate letters, and we would suggest obviously A, B, you'd go for C after that, so we should make A, B, C. Gareth has labelled his triangles and says this is triangle A, B, C. Gareth should have instead used capital letter notation, and the letters should appear on the vertices, the corners there. Those lowercase letters, would indicate the length of the sides there. And Megan has drawn their shape and says the red line segment creates a triangle ABD. Is she correct or not? She is incorrect. There's a couple of choices here. We could go it creates the triangle ABC, or it creates the triangle ADC, or you could even say ACB or ACD. ABD doesn't work. If you were to join those up, you then don't get that triangle there. Okay, it doesn't involve that red line segment. Now, last bit of purposeful practice, that should appear in your workbook. Okay, so I'm just going to put up the answers. So if you just pause now, have a go through the whole of the worksheet, then come back and mark your answers. I'll have them appearing for you now. So, name the longest edge. You perhaps go XZ. You may have referred to it as the other way around, ZX. And in maths, when we have a right angle triangle, which is notated in the bottom right there with that little square, that's a right angle triangle. The edge opposite that is called the hypotenuse. The hypotenuse is the longest edge on a triangle, on the right angle triangle there. Name the shortest edge, ZY or YZ. The angle highlighted in green. Again, because it's an angle, we need 3 letters. The middle letter is the vertex it is at. That's an X. So we will go either ZXY or YXZ. And at which vertex is there a right angle? It's the one we mentioned earlier. It's at vertex Y. If you want to, you could call that XYZ or ZYX. Okay. Next set. Horizontal, CB or BC. Right angle, BCD or DCB. Pair of perpendicular sides. Now, on the next slide, I'm just going to define perpendicular a little bit more, but it's lines that meet at 90 degrees. So we'd look at CD and CB. Acute angle is ABC. The acute angle is one that is less than 90 degrees. Okay, so if you're unfamiliar with these, this next slide you need to copy into your book for me. Perpendicular, it just means at right angles too. So for that example, the red line is perpendicular to the blue line there. They meet at 90 degrees. And those are your various angles, and those are your descriptions of them, which you need to be fully aware of. Okay, last few questions here. Longest edge again, we've got the hypotenuse as BC, or you may have called it CB. Angle ACB or BCA, both mean the same thing. Top right, short edge AB, or you may have called it BA. And where the right angle is, it's at vertex B. We could refer to that as ABC or CBA. Horizontal, BC or CB. The right angle is at ABC or CBA. Okay, so that would be the conclusion of the lesson that we've got today on letter and labelling conventions. So make sure we're using capital letters and that you follow the correct way round, and that does in fact create the shape that you're after. So make sure you've had a go at those worksheets and mark them. There will be a Hecate clip on there, and then next lesson we'll look into line segments in a little bit more detail and measuring them as well. So in the meantime, look after yourselves, Year 7, and speak to you again soon.